Okay, guys, so now let's talk about prime numbers. What are prime numbers? And how do we perform something that is called prime factorization? Very useful in different exercises throughout all these exams. So let's start. What is a prime number? By definition, I hope that you remember which are factors, by definition of factors, okay? Because prime numbers are simply those numbers, okay, that have exactly, I'm going to capitalize this one, exactly two factors. Exactly two factors, okay? When I say exactly two factors, that means I cannot have less than two factors and I cannot have more than two factors, okay? Those numbers that have precisely two factors is what we call prime numbers. And then again, those factors are going to be 1 and the same number, all right? So let's do a couple of analysis and I will give you a list of numbers that I want you to memorize. Not a bad idea for you to know those numbers by heart for these exams in terms of prime numbers. So if we analyze, for example, number 1, and the question is 1 a prime number or not? So let's analyze which are the factors of 1. I can divide 1 by 1 and that's it. So 1 has only one factor, meaning, okay, it has one factor, so meaning that 1 is not a prime number, okay? Let's analyze 2. Which are the factors of 2? I can divide 2 by 1, yes. I can divide 2 by 2, yes. And that's it. I cannot divide it by 3, by 4, by 5. So check out that this guy has 2 factors. So 2 is a prime number. All right. Now let's analyze any other number. I don't know, guys, maybe 15. Let's list the factors of 15. I can divide 15 by 1. I can divide 50 by 2, no. I can divide it by 3. By 4, no. I can divide it by 5. By 6, 7, 8, 9, 10, 11, 12, and by 15, okay? So these are the factors of 15. Check out that here we have 4 factors, meaning that 15 is not a prime number. All right, I hope that with these examples we are clear. Now, let's list the prime numbers between 0 and 20. Okay, those are the most common ones that we will use throughout different exercises in this test. So, let's write it down right here. So we start with 2, yes, it is a prime number. We know that 1 is not, so we start with 2, that is a prime number. 3, yes, prime number. Make the analysis, how many factors does 3 have? 4, no. 5, yes. 6, 7, 8, no. 9, 10, 11, 12, 13, 14, 15, 17, and 19. Okay, these guys here, prime numbers, and hopefully for you to remember. This will be the most commonly used, especially in what we're gonna do right now that is called prime factorization. So keep those in mind. And as a special feature or a special thing that I want you to pay attention to, check out the list 2, 3, 5, 7, 11. Check out that 2 is very special because 2 is the only even prime number that exists. Check out that any other prime number will be odd. So pay attention to these 2, okay? Because 2 is the only even prime number that exists. And that might make a difference depending on the exercise if we are to consider 2 or not, okay? Now, having said that, let's go and let's try to check how do we perform prime factorization. What is that? So prime factorization is a process that we develop in order to find the prime factors of a number. Follow me on this thing, compañeros. Let's take any number. I don't know, 72 comes to my head. If I want to perform the prime factorization of number 72, I write the number here. I draw this line right here, okay? And on the right side of the line, I'm gonna start writing prime numbers by which I can divide, okay? Prime numbers, let's put it in these words, that divide the number on the left. Okay, right here in this column on this side, they can only be prime numbers. They cannot be any other sort of numbers, only prime numbers. So let's start thinking, by which prime number can I divide 72? So let's start making the list of prime numbers, 2, 3, 5, 7, so. If you see it quickly, I can divide 72 by 2, right? The result will be 36. And we continue. 36, I can divide it by which prime number? So I can divide it by 2 again. I will have here 18. We continue now, 18. By which prime number can I divide 18? I can divide it by 2. The result will be 9. Check out that always the results I'm putting them on the left side of the line. On the right side, I'm only writing prime numbers by which I can divide the number of the left. So now the analysis is by which prime number can I divide 9? And I can divide by 3. The result will be 3. And now 3, I can divide by 3 and guess to 1. So you always perform this division, this series of divisions, until you get here as a result a 1. Okay? This process is what we call prime factorization. And here what we're doing is basically what we're saying, that 72 is equal to 2, and we count how many 2's? 1, 2, 3. So 2 to the power of 3 times 3. We have 3 2 times twice, so 3 to the power of 2. Okay? And this guy is what we call the prime factorization of a number. In this case, the prime factorization of 72 is 2 to the power of 3 times 3 to the power of 2. All right? Let's go ahead and let's do another example, just to be clear. Any other number that we want to think of? I don't know. Help me here. I don't know, 120. Okay, let's go with 120. Let's see what do we get. Again, we draw the line. On the right side, I will write only prime numbers, and on the left side, I'll be writing down the result. Okay, so we start again. 120, I can factorize, or I can divide it by, again, prime numbers. Here's the list. We start by 2. Okay, we can divide it by 2. The result will be 60, right? 60, I can divide it by 2. Yes, the result will be 30. 30, I can also divide it by 2. The result will be 15. Now 15, I can divide it by 2. Can I divide it by 3? I hope that you see that yes. The result will be 5. We continue, 5 can be divided by, again here, 5. The result will be 1. We got the 1 here, so we are done with this process. And what we are saying is that 120 is equal to 2 to the power of, help me here, 1, 2, 3, 2 to the power of 3, times 3, that is to the power of 1, let's say, because we only have 1, 3, times 5, again to the power of 1, right? Because we only have 1, 5. This is the prime factorization thing, all right? Here we were doing it in order, you know, starting from 2, then 3, then 5. But check it out that here the order in which you start writing down the prime numbers is at the end of the day not important. Let me show you why. Let's take again this example of 120. Let's do the prime factorization again. But let's start with a different number. Let's not start with 2. I can start this with 5, right? Because I know that 120 is divided by 5. The result of this thing will be 20, 24. Okay? Now 24 I can divide it by, now we can say that we can divide it by 2. The result will be 12. Here I might say that 12 I can divide it by 3. Again, I'm changing the order of these numbers, but pay attention. I comply with the condition that these guys will always be prime numbers. That's the condition I need to meet. So 5 is a prime number, 2 is a prime number, 3 is a prime number. Yes, I can divide 12 by 3. The answer will be 4. Then 4 I can divide by 2. The result will be 2. And here I will get again 2 and 2. And I get here to the 1. I finish my prime factorization. Now, let me change colors here. Let's get the prime factorization. We said here 122 is equal to 2 to the power of 3. Check that. We have 1, 2, 3 number 2s, right? So it's the same, 2 to the power of 3. Times 3 to the power of 1. We have here 3 only once. And 5 to the power of 1. That means that we only have 1 5 right here. You only have 1 5 right here. So it doesn't matter the order. Check it out that when we perform the prime factorization, we have the exact same thing. We have 3 2s, 1 3, and 1 5. So the prime factorization will be the same. It doesn't really matter in which order you start selecting the prime numbers by which you can divide. At the end of the day, if you do things correctly, all the calculations very carefully, you will always have the same result, okay? As a tip, or I don't know, I have the practice, normally I more probably try to start in this side that I start dividing by the biggest number. For some reason, I feel that I start with the biggest number, the number starts getting smaller and smaller, and I kind of feel more comfortable dealing or working with small numbers than with big numbers. But again, you can do as you prefer. At the end of the day, we all should have the same result. Now, there is something else that is interesting whenever we talk about prime numbers and factors, okay, on the prime factorization, and it's this question right here. How many factors does a number have? Check out that what we just did, the previous process, we were able to find the prime factors. But this question refers to all the possible factors of a number. So, whenever we have to find the total number of factors, not only the prime, so prime and not prime factors, this is the process that we will follow. Let's take, I don't know, any number that you want to think of. 100 maybe. Let's go with 100. So we start by doing the prime factorization first, okay? So you know already how to do it. We draw our line and we start dividing by prime numbers. So I'm going to divide by 5 here. The result will be 20. I will divide 20 by 5 again. The result will be 4. I will divide 4 by 2. The result will be 2. And then again 2 divided by 2 to get here a 1. And you know that this is when we say that we are done. So here what we are doing, or what we are saying, is the prime factorization of 100 is 5 to the power of, let's count, we have 2 5s, so 5 to the power of 2 times 2. And we have 2 2s, so 2 to the power of 2, 2 squared. This is what we're saying, okay? Now we know on this process that the prime factors of 100 are 5 and 2. But we don't need to find only those prime factors. We need to find all the factors. So we want to know exactly how many are there. Follow me here. We express and we have the prime factorization. The next step, what we'll do is we will take this exponent, that is 2, and you're going to add 1, okay? So 2 plus 1, this will be equal to 3. We will do the same with the next exponent. In this case, it's 2 again. So we get it down here, and we'll do the same. So 2 plus 1 again, and 2 plus 1 equals 3. And the result of that, this 3 and this 3, we will have to do is multiply. And 3 times 3 is 9. That means that 100 has a total of 9 factors, total, prime and not prime numbers, okay? If you can check, you can list them. If I know that 100 has 9 factors, let's try to find them. We know that these guys should be 1. I can divide 100 by 1. I can divide it by 2. I can divide it by 4. I can divide it by 5. I can divide it by, I don't know, I can divide it by 20, right? Actually, I can divide it by 10. I can divide it by 20. I can divide it by 25. I can divide it by 50. All these are factors. Let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, and well, the last one will be 100. So check out that if I know from the beginning that 100 has 9 factors, and I need to list them, it's possible in these exercises. The idea is that knowing exactly how many, because we can guarantee that we are not missing or that we don't have more. We need to have exactly 9 in this case. All right. So that's what you do. Let's do it again with another example. Okay. Let's take the one that we did before. I think that it was 72 or 74. I don't remember. I think it was 72. We perform the prime factorization, and we start. I can divide 72 by 2, right? The result will be 36. which I can divide by 2 again, is 18. 18 I can divide by 2, which is 9. 9 I can divide by 3, the answer is 3, and 3 I can divide by 3, and I get 1. Again, this is where we're done. And what we're saying is that 72 is equal to 2 to the power of 1, 2, 3, 3, times 3 to the power of 2. I have 2. Doing exactly the same as we did with 100. We take the exponent, in this case is 3. So it's going to be 3 plus 1. And this we will multiply with this guy. So we know that we do the same. We get 2 plus 1. Again, we add 1 to the exponent and we multiply. So 3 plus 1 is 4. 4 times this will be 3. This whole thing will be 12. So we know what we're saying is that 72 has 12 factors. Again, total, prime and not prime. You can start making the list, you can start listing all the factors, but at the end, the 12, what it helps us is that we know in advance that we cannot have less than 12 or more than 12. 72 has exactly 12 factors. This process, even though it might not be the most common thing, but I can guarantee that in any given exercise, in this test, this is something that will be useful for you to know. Okay, I hope that is clear enough. Any doubts that you may have on these concepts or in this math review, please email us and I'll get back to you as soon as possible.